So there's been quite a revolution within the last sort of 5 years in what you probably call bulbs, but what are officially called lamps. So that's what lighting engineers like to call them. And it all revolves around these new LEDs. Philips, a big sort of manufacturer of lamps, it now only produces LEDs. And they're used internally and externally. And you can see the sort of difference that they provide, some positive ones and some potential downfalls as well. So on the left, this is just a lighting scheme that a local government has introduced. You can see they've gone from a sodium lighting scheme to an LED lighting scheme. And they saved allegedly about 65% on their energy costs by doing this. So the sodium is a very orangey kind of light. So there's very poor color rendering. If you're under low pressure sodium and say you like Smarties and you really like the orange Smarties, you could tip the entire Smartie container out in your hand and all the Smarties would actually be of an orange color. And you can no longer use low pressure sodium in street lighting because it's got such a poor color rendering index. It's basically 0 to 100% scale, and 100% is meant to sort of represent daylight conditions, and low pressure sodium actually gets 0. So as you can see, there's a vast improvement in the color rendition if you look at the picture on the right, which is illuminated by LED. But you can see there's also a big cutoff. This is something, you know, if you're responsible for exterior lighting and you're just replacing like for like, you can see that compared to the sodium lighting, there's a big cutoff between the illuminated areas and the non-illuminated areas. The low pressure sodium on the left, that sometimes doesn't just have reflectors in the lamp, it also has refractive prisms, and it spreads out the light very well. If we look on the right, there's a clear sort of dividing mark between the illuminated area and the dark area. So this is the actual HSG guidance on light, and if you're familiar with this document, it is pretty out of date, and it doesn't even mention LED lamps because they probably just, you know, weren't around when it was written. So this is a new type of lighting. So basically, to summarize so far, you know, humans, we've evolved over millions of years, and we've not been exposed to this new artificial light, which is changing all the time. So let's sort of have a change of scene. This graph here was produced quite a few years ago by the HSE. I remember looking at it the first time, and I had a shock as I looked down, because the first 4 is exactly what I'd expect to be the causes of cancer in the UK. They're chemical agents, asbestos. There's 2 types of fatal cancers produced by asbestos. Silica, there's a pneumocinosis, as well as cancer. Diesel engine exhaust emissions. You've probably heard about the Volkswagen scandal recently. This is why people were particularly concerned, because 3 years ago, IARC, the International Agency on the Research on Cancer, made diesel fume an actual human carcinogen. So the fact that there's a lot around is going to affect all our health potentially. So if we come down to number 5, it's shift work. So that's not a hazardous chemical agent. That is just people working at a different time in the day, or in the 24-hour day. And according to these statistics, over 500 people each year in the UK are dying as a result of doing shift work. Now, if we compare that to the people that were killed last year due to accidents at work, it's 142 people. So over 3 times the people are getting killed due to just doing shift work. And the reasons, the sort of diseases that it potentially cause are breast cancer and diabetes, And there's also been correlations with potentially obesity, strokes, and heart attacks. So the IARC, this is that International Agency on Research on Cancer, obviously does big reviews of lots of different hazardous substances. And when it did look at shift work, this was back in 2010, it made the conclusion that shift work that involves circadian disruption, we'll talk about that in a minute, is probably carcinogenic to humans. So they didn't give it their top category, but they gave it their second to top category. But they went further. They said there is sufficient evidence in experimental animals for the carcinogenity of light during the daily dark period, so the biological night. So this is quite disturbing and worrying stuff, isn't it? So what are these circadian rhythms? Well, it's basically a 24-hour cycle, and it's not just us humans that have this. Pretty much every living thing on the planet has a almost 24-hour cycle. And that includes animals, plants, and even microbes. And we tend to refer to this circadian rhythm as our body clock. And one of the most important things it does for us is it creates this desire to sleep, and this generally occurs between midnight and dawn. So what then controls our circadian rhythms? Well, it's been sort of established for quite a long time. There's a gland in the center of the brain, and it produces this hormone called melatonin. So melatonin production controls the sleep-wake cycle. So it's produced in the sort of evening, and it makes us feel sleepy. It's not the only reason, but it's one of the main reasons. So this melatonin, as well as helping us to sleep, creating that feeling of tiredness, it's been shown to support the immune system and have cancer protective properties and health protective properties. However, exposure to light reduces the production of melatonin. And there's increasing evidence that it's not just the amount of light, but the sort of type of light. And it's really associated with sort of the blue type of light, so the blue dominant light. So let's just have a sort of reminder of how the human eye works. We've actually been studying it for about 150 years, so we thought we knew everything about it. So we knew there was cones. These are the things that give us our color vision above 3 lux. And then we've also got this quite cool night vision, so we can actually see down to about 0.1 lux. It's in black and white, but our brain typically tells us it's a color, but we're actually seeing at night in black and white. So this chap here, he's called Russell Foster, and he works at Oxford University. Before he came up with his theory, people believed that it was these cones and rods that was controlling our biological clock. But he thought there was, something else in the eye that was producing this effect. So he did some research. It was initially sort of animal studies. So he had some mice, and they were sort of developed not to have any rods and cones, these visual receptors in their eyes. But the mice still demonstrated that they had the sort of normal circadian rhythms. They still slept at night, and they got up in the sort of daytime, and that was their active period. And he found a few humans who had this sort of same effect. And it was a person who had completely lost their cones and rods in their eye due to quite a nasty, rare genetic disease. But they still got up in the morning and sort of felt sleepy and tired at night and went to bed at night. However, there were also people that had sort of terrible accidents and lost their eyes completely, and they'd lost their body clock, and they slept randomly day or night. So it's now been established, due to this work, that there's a third set of photoreceptors, these brightness detectors, and they're not linked with vision. And there's a new sort of photopigment that's been found that's particularly sensitive to light at 480 nanometers wavelength. And if we look at that visible spectrum of light, this is the sort of light that we see during a rainbow. It's when we sort of see it split down due to the raindrops acting as a prism, and we see all the different colors within the white light. So if you see 480, you're in the blue region there. So artificial blue rich light to the eye mimics the daylight, and unfortunately it suppresses the melatonin and inhibits the sleep process. But the human body, we've been programmed to be alert and most awake during periods of bright blue light. So through evolution, you know, we were going to be more successful hunters during the daytime. So we wanted to be alert during the daytime, but we needed rest as well. And we wouldn't be good at hunters at the night. So we developed sleeping and resting during the night. So there's something here called the color temperature. We've got some of the sort of traditional lights and their color temperature. It's similar to that visual spectrum that we were looking at, but the actual color temperature is all sort of related. The sort of background to it is of the heating of metal, and the temperature refers to the color of the metal as it's heated. But for us, from a visual point of view, the sort of lights at the red orange spectrum and the yellow spectrum are like soft lighting. They're sort of comfy, cozy lighting. And then the sort of lights towards the blue end region, they're the sort of harsher, sort of more sort of ugly lights, if you like. So if we look along the bottom, we've got our high pressure sodium that we talked about a few minutes ago. So that is obviously a very orangey, reddy light. And then as we come along, we've got the sort of traditional light bulb, and that's at 2,700 degrees Kelvin. So you can see that first light bulb, that was quite a warm, orangey kind of yellowy light. But then some of these sort of newer artificial lighting, they're becoming progressively colder. And we can see fluorescent is up to 4,200 degrees Kelvin. And then a daylight metal halide lamp is at 5,500. So where does the new LEDs come in on that scale? Well, initially, when they were first developed, they came much higher. They were around 6,000. So they were a very blue dominant light. So I think I've just explained all that a bit prematurely. So these new LED lamps are very blue dominant light and much more bluer than our sort of traditional light bulbs. So therefore we can sort of conclude that this blue rich light is not going to be, if we expose ourselves during night time, it's going to disrupt our sleep, and it's potentially going to reduce the amount of melatonin we produce, which is going to have these good health properties. And believe it or not, you can see in the bottom picture there's a sort of night light there. Even when we're asleep, some of that light, about 7%, will be getting through our eyelids and into our eyes. So this is a potential problem, isn't it? So how can we mitigate it? How can we reduce the risk? Well, the sort of general advice, even though this is obviously quite a new thing, some of this research has been done fairly recently and we've just become aware of it. But we want to try and mimic nature with our lighting. So in the daytime, it's actually quite good to have bright blue dominant daylight. So either the daylight itself or even artificial light that's simulating blue light. But just to sort of, there was a study of office workers, and they found that the people that were situated near the windows, that were getting exposed to some daylight through the windows, actually slept for 46 minutes longer. So this was nothing to do with their exposure during the night, but having daylight during the day was actually helping them sleep. So it's not just about stopping blue light during the evening, it's about encouraging it during the day. So the sort of general advice is to have as much natural light as possible in your workplace where practicable. But at night, we need to do the opposite. We need to prevent exposure to this blue cold light, because we want to encourage this melatonin production and have normal sleep patterns. And even though those first LED lights were very blue dominant, and it's the worst sort of color from a point of view of stopping melatonin production, they're now available in the same sort of warm color temperatures as we had our traditional lighting. And even fluorescent lamps, you know, we associate them with that sort of cold light. With coatings on the actual lamp itself, you can produce a soft light from those as well. So the technology is available and out there. And with regard to phones and tablets, there's now an app that you can download that will apparently, I've not done any sort of scientific study on it, but it will reduce the blue dominant LED backlighting during the evening and night periods. And this may be another solution in the future, that the color temperature of our lighting just changes throughout the day. That will be programmed to produce the sort of light that we need at the right time. Now, we talked about shift work earlier on, and that's obviously going to be a trickier issue to actually solve. I think more research and investigation is going to be needed. But there are, you know, potential control approaches. There's these light therapy or light boxes. So we know light has this big impact on us now. So when we want to be alert, we can almost replicate that artificially, and by going into these light boxes. And there you can actually artificially as well produce melatonin, and it may be in the future that we can actually supplement our melatonin artificially. But I should put a sort of advise that I'm not recommending this at the time, because I don't think it's been, you know, it's not under any kind of medical surveillance at the moment. So that all needs to be checked out, that that's safe to do. And for shift workers who are sort of finishing their work just as the morning starts, we can potentially sort of bring them down into a sort of sleep mode by wearing certain types of glasses on their way home, so that they avoid that bright light that they're now getting in the morning. And there's certain dark glasses and blue light filtering glasses that can be used to filter out the blue and bright lights, so they can wind down and sleep as we would at night time. So that comes to the end of the session. I think Chris has been checking out to see whether there's any questions. Chris, are you there?
Yes, Paul, sorry, I put myself on mute while you were doing the presentation, and then therefore couldn't find the button to unmute myself. But thanks, that was really interesting. I found that was a really good one. So I have got a couple of questions that have come through. One of which is, what would be the best approach or strategy to carry out a lighting risk assessment in an open plan office under the health and safety regs to ascertain whether lighting is a significant risk to employees' health? What would be the and then repeated. So yes, what's the best way of doing a lighting risk assessment?
Well, you know, there's new stuff to consider, isn't there, with this sort of work that I've sort of reviewed in this session, but there's also all the traditional things as well. So it depends on the workplace, you know, what people are doing, you know, how much light they need. Generally speaking, the sort of more close work there is, the more light or illumination is required. So there's lots of things to take into account. It's not something, you know, that I can really summarize, you know, briefly in one sort of answer, but there is guidance out there with regard to this, and it's you know, many different aspects that you need to take into account. If I knew the sort of workplace, you know, we were talking about, then that would be easier to answer. But there's, as I sort of said at the beginning of this session, there's sort of safety issues, there's all kinds of ergonomic issues, and then there's this sort of new issue that there's potentially is. So it seems very simple, doesn't it? It seems quite a simple question, but there's lots of different elements to it. And I think one thing that is required, we had a quick sort of look at that HSE guidance. There's a massive need for that to be updated, because it is very out of date and almost useless now. All the lamps have changed, and also the working conditions, like VDUs. You still see pictures of old computer screens that no one has used for about 20 years that used to produce all different types of glare, which just doesn't happen anymore. So we need new and up-to-date guidance to help people to do these risk assessments. And like most things in life, it's all interlinked with other things, so it's part of your sort of DSE assessment.
Absolutely. Well, I think that the DSE rigs are there. Some new guidance is in the pipeline. I'm not sure we exactly know when it's coming, but I think hopefully it will include some change to light as well. So, so I've got another couple of questions. One is, this is an interesting one. How does lighting affect the office space with those who are colourblind? Does it affect them in different ways?
That's a good question.
On the spot, that one.
Yeah, colorblind. Like I say, I'm not a huge expert on all this issues. I wouldn't have thought it would have a big issue, but like I say, it's sort of almost a medical question, that one. I would say it wouldn't have a big effect. There's certain things, obviously, there's different types of color blindness, but I wouldn't think changing the lighting is going to sort of improve or decrease their ability to detect certain colors.
Okay.
But I could be wrong.
I guess you have to go deep into the meanings of cones and rods and that sort of stuff, and it's what effect that has on colour blindness. But so I've got another question about
the big, if you're interested in the colour rendering, then there's information on each lamp regarding colour rendering. So those sodium lamps, it's nothing to do with being colorblind or not. Everybody under a low pressure sodium lamp is going to see orange, and it's due to the way that the color rendering is. So you can improve the color rendering in your workplace, or especially in your external workplace, by changing the lamps. What I didn't say is the new LED lamps, they can go from 80% to 98%. So they're actually producing, far better color rendering, for the external lighting environment than we've ever had in the past. They're very good with regard to color rendering.
Excellent. Okay. Is there any evidence or case studies where light has been used to improve the well-being of shift workers?
Well, there's probably been sort of studies on this. I think more studies are needed. The problem with shift workers, and we're talking, there's lots of different types of shift workers. There's people that sort of work at night, and there's people that work sort of rolling shifts, so nurses and sort of police. And it's not just the lighting, obviously, that has the sort of detrimental effects, but it's so one approach for shift workers is just to sort of put them in the wrong time, if you like. So their night, or our night, is their day, and our day is their night. And that's seen, if you can, simulate that all the time, to be the best way, the most healthy way of working shifts. But unfortunately, even if that is possible, even if you can change your own body clock, the rest of society are working, in the opposite way that you are. So, the postman is still going to knock on the door, the kids still need to go to school. So, there's lots of challenges to getting to sleep when you're working on night shifts. So, the idea in America now, they are, the commercially available glasses for shift workers to wear on their way home. But again, that's assuming that they're going to go to sleep, pretty soon as they get home. They may have other things in their lives, and they may want to sleep a bit later. You're probably aware that there's, even in the sort of normal sort of non-shift workers, there's people that like to get up early, the larks, and there's people that like to go to bed late, and the owls, and they actually have a slightly different 24-hour clock to each other. So there's personal variation depending sort of what sort of person you are, and it's a big challenge, isn't it? I think.
Absolutely.
Shift work.
Yeah, absolutely. I think it's something that, yeah, I mean, maybe some of the work that you do, and as the evidence comes out, then perhaps we can deal with them better. But yeah. Brilliant. So we're running over time. So and there's been quite a few more questions that have come through. So what we'll do, Paul, I'll send these to you after the webinar, and hopefully we'll be able to get as many of them answered as we can, and we'll make them available with the recording that we'll put online as well. So thank you very much to everybody that's attended today, and we haven't got one in December, so we will see you in 2016. Thank you very much. Thank you, Paul.